This video is going to teach you how to solve quadratic inequalities. Okay, so the first step, so we know this is a quadratic because the exponent, the highest exponent is a 2, has a degree of 2, and we know it's an inequality because it has one of these symbols here. So that's how you know when to use these steps when you have a quadratic inequality. So the very first step, step 1, is you are going to solve the problem as if it was an equation. So step 1, you're going to get rid of the inequality and solve this problem instead. We'll talk about why in a moment. So to solve this equation right here, whenever it has an exponent, there's multiple methods that we learned in this chapter of how to solve an equation with the highest exponent of 2. So I like to factor or use the quadratic formula. So to do that, I need it to equal 0. So that is why I know to set it equal to 0 because of the method I am choosing to use. So if I want to factor this, I would have to think of what multiplies to negative 40. And it has to add to negative 3. So since it has to multiply to since it has to add to a negative, we know the bigger number is the negative one. And then the smaller one's positive because it has to multiply to a negative, so a negative times a positive. And we would see that 5 and negative 8 would work. So we would have x plus 5 and x minus 8. And then we would set each of these equal to 0. And again, if you prefer to use a different method that you've learned from this chapter, that works. Okay, so that was all step 1. Figure out what your x values are that would make this equation equal. So you're going to solve it like it was an equation. Step 2, what you just found are your solutions that are going to be your boundary numbers on a number line. So you're going to make a number line. So step 2 is to make a number line and put your negative 5 and 8 on the number line. So negative 5 and then 8. So remember the smaller numbers should go first. So that is step 2. Step 3 is you're going to choose any number you want. So any number you want from each of the regions that we just created with the number line. So step 3 is pick whatever number that would be here on the number line. So any number bigger than 8. So for example, I can pick 10. Then I would pick any number in between here. So in between negative 5 and 8. So I'm going to go ahead and I'm going to pick, I'll go with 3. 3 is in between there. And then any number less than negative 5. So I'm going to go with negative 6, for instance. Whatever numbers you want that would fit in the regions. So that was step 3. Step 4 is you're going to substitute. So plug in, substitute. Those numbers we just picked back into the inequality from step 3. Substitute those numbers from step 3 in for x. So step number 4 is we're going to go back to the original problem that we were given. So not the equation. So these two numbers right here make it equal 40. We don't want it to equal 40. So that is why we are going to put open circles on the negative 5 and 8. Because again, these two numbers, when you plug them in here, make it equal 40. And it doesn't have the line underneath. So that's why we're putting the open circle. So now we have to check the three numbers we chose. So I'm going to go ahead and start with the negative 6. I want to see if negative 6 is a solution to this inequality here. So I'm going to go ahead and plug in negative 6 here. And negative 6 squared is 36. And then negative 3 times negative 6 is positive 18. And then 36 plus 18 is 54. Okay, then I'm going to read this and think of this like Pac-Man. It should be going towards what is more. So since this is a yes and it works, then that means any number over here in that region is also going to work. Okay, so now we're going to do this again. So now we're going to pick the number we chose here. So again, you don't have to pick 3. You could pick 0, 1, 2, 3, negative 4, negative 4.5, whatever number that would fit in between these two numbers. Anything in that region. So I'm going to go ahead and pick 3 now. So I'm going to plug in 3. And I'm going to have 9 minus 9 is 0. And then I read this. Is 0 greater than 40? No. So then I'm not going to shade over here. I'm going to leave it empty. All right, almost done. So now we're going to do it again. Go back to the original problem and take out the x, and I'm going to put the number I chose, which was 10. If you don't want 10, pick something else. So I'd have 10 squared is 100, minus 30 is 70. And this is true. 70 is greater than 40. Yes. So that means we're going to shade over here. So that all was step 4. So then step 5, you're going to write your solution in interval notation. And remember, we always go left to right when we do that. So we're going to look at our graph here and go from the left to the right side. So on the left side, it's going infinitely to the negative side, so negative infinity. And then it stops at negative 5, and there's a parenthesis because x can't be negative 5. If we plug it in here, it won't work. So again, if we plug in negative 5 for x, so if I do that just to show you why there's a parenthesis here. If I go back to the original problem, which was this, and we plug in negative 5 here, it would get us 40. And this does not work. That is why there's a parenthesis here, because this number next to it doesn't work. It's not equal to. So again, these two numbers right here have open circles because they are no. They don't work if you plug them in. It makes it equal. So that's why you're putting the parenthesis here. And then we're going to put the union symbol because we have that space right here, nothing shaded. So it's the union with 8. And then it goes infinitely to the positive side. And then that would be our solution. So again, what we were trying to find is what numbers, if we plug them in for x, are greater than 40. Now there is a way to also solve this by graphing. So this is algebraically. If it said to solve by graphing, we would type in that function. We would set it equal to 0. So we would type this in right. We would type this in right here, and then look at the graph, and we could see when is the graph going to be greater, because this symbol right here was a greater than symbol, and you could see that the graph is greater up here. So from negative infinity up to negative 5, it's above the x-axis. And then from 8 to infinity, it's above the x-axis. So all in between, so this part right here, this part right here, the graph goes below in this part right here. It's going below the x-axis. So that is why this is the correct answer, because any number less than negative 5 and any number greater than 8 would make this inequality true.